Input recognizers can make two types of errors when trying to distinguish input actions. False negatives, where the system fails to recognize an input action that the user has intentionally performed, and false positives, where the system recognizes an input action when the user has not intentionally performed one. Existing work has explored approaches to minimize these errors, but tends to assume that error type preference will be stable for a given application. But if a single command gesture can activate many different actions, the relative cost of these errors could vary dramatically. To inform adaptive approaches to input recognition, we conducted a study where the time to recover from each error type was manipulated, and error type preference was measured. By repeating this over many differences in temporal cost, we can model how temporal cost drives error type preference, and reveal hidden costs and biases not explained by temporal cost alone. This video provides a demonstration of the study task. The goal of the study task is to search a grid of tiles for target items and select them with a click. The system can inject a false negative when the user finds a target item and clicks. The system acts as though no click has occurred. To recover, the user must reopen the tile and click to select it. The temporal cost of error recovery is manipulated through how long it takes to reopen the tile. The system can inject a false positive when the user finds a non-target item and goes to move on. The system acts as though a click has been performed, selecting the tile. To recover, the user must reopen the tile and click to deselect it. As with false negatives, the temporal cost of recovery is manipulated through how long it takes to reopen the tile. Each participant completed 13 blocks. In each block, the temporal cost for each error type was fixed, and 6 errors of each type were randomly injected. After each block, participants were asked their error type preference. They also rated the strength of their preference and provided a frustration rating for the block. To test how high-level task influences error preference, 2 task variants were developed. In the time pressure variant, participants performed the tile task while a progress bar counted down. If the progress bar became empty, an animated cat would eat a slice of pie, and the user would have to pay a 4-second time penalty at the end of the page. In the split attention variant, participants performed the standard task while also monitoring a changing word at the top of the screen. They were instructed to press a key on the keyboard when animal words were displayed. For any words they missed, there was a 4-second penalty at the end of the page. See the paper for full study details and results.